Hello everyone. So in this video, you will learn on how to interpret the phase diagram for a simple substance such as carbon dioxide and water. So there are three states of matter, which is solid, liquid, and gas. You can recognize the presence of the different phase because there is an obvious boundary between them. For example, ice in water and also oil on water. If you have an ice floating in water, you can see there are two different phases here where we have ice in solid phase and also water in liquid phase. Oil that floating on water also consists of two phases, but in this case we have two liquid phase. A substance adopts certain phase depends on the pressure and temperature that it experiences. For example, at very cold temperature, water exists as solid ice. At room temperature, water exists in liquid form. At very high temperature, water becomes steam. A phase diagram will tell you exactly what phases are present at any given pressure and temperature. Phase diagram has pressure on the y-axis and temperature on the x-axis. Phase diagrams are divided into three single-phase regions, which is solid, liquid, and gas. The lines and curves that separated these three regions are known as phase boundaries. Along the phase boundaries, a substance exists simultaneously in equilibrium between two states that border the phase boundary. This point here that labeled as O is called the triple point. Triple point is the point at which solid, liquid, and gas exist simultaneously in equilibrium. The point here that labeled as C is the critical point. Critical point is the highest temperature at which a gas can be liquefied. Above this point, the liquid phase cannot exist regardless the pressure. What actually is this line separating the solid and liquid areas at the diagram? Let's label it as A. So the OA line is a freezing or melting line. On this line, solid and liquid exist in equilibrium. Let's label the curve that separates solid and gas as B. This OB curve is the sublimation or deposition curve. On this curve, solid and gas are in equilibrium. The OC curve is the vaporization or condensation curve. On this curve, we can determine the boiling point of a substance. A substance exists as liquid and gas in equilibrium on this curve. Normally, the melting and freezing line for a phase diagram slope is a positive slope. For example, here we have the carbon dioxide. This is because the solid carbon dioxide is more dense compared to the liquid carbon dioxide. At this line, we can see the melting or freezing point increases when the pressure increases. Carbon dioxide does not have a normal boiling point. This is because the liquid phase does not exist at 1 atm. The triple point here, as we can see, for carbon dioxide is 5.1 atm, larger than 1 atm. So, instead of boiling, solid carbon dioxide sublines at 1 atm and negative 78.5 degrees Celsius. Unlike carbon dioxide, water has a negative slope of phase diagram. This is because the liquid water is more dense compared to the solid water. As the pressure increases, we can see the melting or freezing point decreases. The normal melting and freezing point is 0 degrees Celsius and the normal boiling point is 100 degrees Celsius. Supposedly, if you have a substance starting from point A increasing the temperature at constant pressure until point E. Starting at point A, the substance is in solid phase. At point B, the substance is in solid and liquid in equilibrium. At point C, the substance is in liquid phase. At point D, the substance is in liquid and gas in equilibrium. At point E, the substance is in gas phase. We can also playing it around by changing the pressure at constant temperature. For example, starting from A, the substance is in solid phase. Decreasing the pressure until point F, the substance is in solid and gas in equilibrium. At point G, the substances are now in gas phase. Going from solid to liquid, it is called as melting process, while from liquid to solid, it is called as freezing process. From liquid to gas, it is called as vaporization, while from gas to liquid, it is called as condensation. From solid to gas, we have sublimation, and from gas to solid, we have deposition. So that's how we interpret the phase diagram. See you next time.